This is a short lesson on using millimoles. We're going to find that it's going to make titration calculations easier, especially when we're using BCA or ICE tables. So we know normally that when we're making ICE tables or when we're figuring out molarity, we've always used moles of solute over liters of solution. Well, we will get the exact same value if we divide both the top and the bottom by 1,000, which is what we have here. Millimole of solute over milliliter of solutions is equal to millimole over milliliter, which is the same as molarity. So what we're going to do is we're going to calculate an example of a strong acid being added to a strong base, and we're going to calculate the pH after adding 30 mLs of 0.05 molar HCl to 40 mLs of 0.08 molar KOH. We're going to work at using the mole method, and then we're going to work at using the millimole method. So let's do the mole method. So we're doing a BCA table because this reaction goes 100%, so it's a limiting reagent table. And so we go, okay, I've got to use my liters, so I'm going to have 0.030 liters times 0.050 molar equals 0.0015 mole. And that's for my hydrogen, so I'm going to put 0.0015 in here. And then I do the same thing for the potassium hydroxide. I'm going to take 0.040 liters times 0.080 molar, and that's going to be 0.0032 moles. And I'm going to put it up here, 0.0032, and hope that I haven't dropped any zeros. Okay, there's my limiting reagent, so minus 0.0015 minus 0.0015, and do my subtraction. That's 0, and I have 0.0017. I didn't drop any zeros. Good. All right, now I'm ready to figure out my molarity, and I'm going to take 0.0017 moles, and I'm going to divide it by my total, and that was 30 plus 40, but I have to remember to put it into liters, so that's 0.030 plus 0.040. All right, so that's going to be equal to 0.0017 over 0.070, lots of zeros. All right, now I calculate that, and that's 0.024 molar, and that is my hydroxide ion concentration, okay? So I have to remember that, so I'll figure out my POH and then my pH, and my pH is going to be equal to 12.38. So I had many opportunities up here to drop a zero. Now, let's do it using millimoles. So now I need moles of H plus, and in fact I'm doing millimoles, so let me write that down. Millimoles of H plus, and that's going to be 30.0 times 50.0. Excuse me, not 50.0, that should be 0.05. Let me fix that. 0.05. And that's going to be 1.5. And then I'm going to do the same thing with the hydroxide. And that's going to be 40 times 0.08, and that's going to be 3.2. And I put my values in, so I'm going to have 1.5 millimoles and 3.2 millimoles, 1.5. minus 1.5, 0 millimoles, and 1.7 millimoles. Okay, so my hydroxide ion concentration will be equal to 1.7 millimoles, and now I need my total liters, and I look up here and I go, I have 30 plus 40, I can do that in my head and not worry about losing zeros. So that is 70 mLs, and I calculate that, and it equals 0.024 molar, just like the other one, and again the pH is 12.38. So we can see here that we have much less opportunity to make dumb mistakes by losing zeros. Okay, so you are going to try this one here. Calculate the pH after 16 mLs of 0.4 molar HCl is added to 18 mLs of 0.3 molar KOH. Try using the millimoles. Pause the video while you work the problem. Okay, here's your solution. Hopefully you had this table. You had 6.4 millimoles based on 16 times 4, and then you had 5.4 based on 18 times 0.3, and you went through your math and you had 1 millimole over 34 mLs total, and then your pH was 1.53. So hopefully you will find this an easier way to do the titration problems.